In an earlier video, I mentioned that every time a surgeon attempted a transplant, they would come up against a mysterious biological force that attacked organs. That mysterious force we now understand as rejection. And this video is about the connection between rejection and cows. In 1948, the English zoologist and immunologist Peter Medawar met Hugh Donald, who was the head of the Animal Breeding Research Organisation in Edinburgh. Donald asked Medawar how he could distinguish between fraternal and identical cattle twins. This was easy, Medawar said. You just exchange skin grafts between the twins and see how long they last. If they take, they're identical twins, but if they don't, they're fraternal twins. A few months later, Donald called Medawar over to a farm near Birmingham to do the grafts himself, and he couldn't explain what he found. All the grafts took, even those between fraternal twins. He did some reading and found out that before birth, cattle twins share a placenta and blood-forming cells. After some experiments, Medawar reflected that the biological force was an immunological response, with the recipient's body fighting what it thought to be foreign cells, trying to destroy them like a virus. But this didn't happen in the cows because they shared their cells before birth, and because of this had acquired immunity to one another. In his lab, Medawar tried to engineer this immunological tolerance in mice by injecting one mouse with the cells of an unrelated one. And it worked. The mice could also acquire immunological tolerance and could accept grafts from an unrelated mouse. Transplant surgeons had no immediate use for this discovery because even though it would work in humans, patients would have to have been exposed to the cells of their donors before they were even born. So unless the donor and recipient were twins, organ transplants would routinely fail for many years to come. But it did mean that scientists now had a biological mechanism to study, and eventually, by the 1980s, effective drugs were identified that helped suppress the immune system so that it didn't attack the donor organ.